Now, the next ones that we're going to do is dilations. Now, please remember this. To dilate is to live long. No, actually dilations mean that you are stretching or changing the shape of the graph, making it larger or smaller or something like that. Now, let's take a look at y equals the absolute value of x again. Now, what I'm going to do now is I'm going to also graph y is equal to 3 times the absolute value of x. And let's start out by looking at it on the calculator. So y equals absolute value of x. Down here, we're going to put a 3. Down here, we're just going to clear that one out. Now, watch carefully. First I'm going to get the v, and then I'm going to get 3 times the absolute value of x graph. Now, notice what I got a v for the second one, but it's steeper. Now, why would that be? Well, let's take a look at it. In y is equal to the absolute value of x again, we had 0, 0, 1, 1, negative 1, 1, 2, 2, negative 2, 2, 3, 3, negative 3, 3. So we get the v that we're used to. But now in y is equal to 3 times the absolute value of x, when we put 0 in, 0, absolute value is 0. 0 times 3 then is still 0. When we put 1 in, we take the absolute value of 1, that's 1, and then we multiply by 3. So y is 3 times what it was in the absolute value of x graph, the blue graph. If I put negative 1 in, absolute value of negative 1 is 1, and then 1 times 3 gives us 3 again. If I put 2 in, absolute value of 2 is 2 times 3 is 6. So I get 6 instead of 2 for this one. If I put negative 2 in, I also get 6. So notice I still get the v, but my graph is steeper. In fact, one way of looking at this is everything above the y-axis, above the x-axis in the blue graph is 3 times as high as it was before. Now what that means is something that was actually on the x-axis is no height at all. If you multiply 0 by 3, you're still going to get 0. So I'm fond of saying to students with dilations, what happens on the x-axis stays on the x-axis. It's kind of like Las Vegas. But everything above the x-axis, if you're multiplying by 3 after you perform the function, is 3 times as high as it was. Now notice again, this is a vertical effect, and we're doing the multiplication after the function has been performed. Now, if we multiply by 1/3, or let's multiply by 1/2. So in other words, we're going to do y equals 1/2 absolute value of x. Now, I have 0. Absolute value of 0 is 0. 0 times 1/2 is still 0. Then if I put 1 in, absolute value of 1 is 1. And then I multiply by 1/2, so I get 1/2, 1 1/2. If I put 2 in, the absolute value of 2 is 2. And then 1/2 times 2 is 1. If I put 3 in, the absolute value of 3 is 3. And then 1/2 times 3 is 1 1/2, or 3/2. Let's put negative 1 in. Absolute value of negative 1 is 1. 1 times 1/2 is 1/2. If I put negative 2 in, absolute value of negative 2 is 2. 1/2 times 2 is 1. So notice what I'm getting here is a graph that has half the height of the original graph, the blue graph. And what we do is this is also a dilation. It's a vertical effect because we're multiplying after we perform the function. But we call it a compression, a vertical compression, because what's happened is this blue graph has been compressed down. Now notice again, what happens on the x-axis stays on the x-axis. If we multiply 0 by 3, it's still 0. If we multiply 0 by 1/2, it's still 0. So when you're doing the vertical dilations, the compressions and stretches, the part that's on the x-axis stays there. Now, if you had something that was below the x-axis, it would be 3 times as far below or 1/2 times as far below the x-axis as it was before. Now, we ask ourselves the question, what happens if we multiply x by a number and then perform the function? Okay, now that, as Scarlett said, is an entirely different question. So let's start out. Y is equal to absolute value of x. Now, with y is equal to the absolute value of x, we know again that that's 0, 0, 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, negative 3, 3. So that's the standard v that we get. Now, what happens for y equals the absolute value of 3x? Now, this one may be a little bit difficult for you to see, but let's do this. Let me start out by asking, what do I need to put in for x so that I'll be taking the absolute value of 1? I'll ask the question again. What do I need to put in for x in the red function so that I'll be taking the absolute value of 1? Well, the answer to that is 1/3, because if I put 1/3 in for x, I will multiply 1/3 times 3, and that'll give me 1. So at x equals 1/3, I'm actually going to be taking the absolute value of 1, which is 1. Now, at 2/3, I will be putting 2/3 in, but I'll be taking the absolute value of 3 times 2, or 2, which is 2. So notice what's happened is that this 1 right here has been compressed in, and this 2 right here has been compressed in also. So what really happens when you multiply x by a number before you perform the function, it compresses it horizontally to 1/3 its original width. Now, once again, that's counterintuitive. We're multiplying by 3, but what that ends up doing is compressing it horizontally to 1/3 of its width. Now, if we take a look at y equals the absolute value of 1/2 x, let's ask ourselves this question again with the green graph. What do I okay, first of all, if I put 0 in, of course I get 0. What happens on the x-axis, or in this case, what happens on the y-axis stays on the y-axis. But now, what do I need to put in for x in the green function so that I'll be taking the absolute value of 1? I'll stop. I'll ask the question again. What do I have to put in for x so that I'll be taking the absolute value of 1? Well, obviously 2, because if I put 2 in for x, 1/2 times 2 is 1. So when I am putting 2 into the graph, I'm taking the absolute value of 1, which is 1. When I put negative 2 into the graph, negative 2 times 1/2 is negative 1. I'm taking the absolute value of negative 1, which again is 1. So notice what happens is we have a graph that the 1 has been put out to 2, the negative 1 has been put out to negative 2 here. So what happens is when I multiply by 1/2 before I perform the function, I'm compressing the graph horizontally by a factor of 1/2, or in other words, I'm dividing by 1/2, which is the same thing as multiplying by 2. So in